Good afternoon, good morning, everyone. Thank you for joining Megger's webinar. Today's topic is cable identification and phase selection. We're very honored to have our cable specialist from UK, Tony Walker, to be the presenter. Please note that you are automatically muted to prevent any background noises. During the webinar, if you have any questions, please type into the question panels and we'll answer them during the Q&A sessions. So Tony, let's start now. Thank you.
Hello everyone, my name's Tony Walker. I'm an application and technical support engineer for Megger based in the UK. My specialisation is high voltage cable, fault location and diagnostics. Today we're going to talk about cable identification and phase selection. We'll start the presentation. What we're going to look at today is in the energised cables, the pulse method, single or multi-core conductor cable, low voltage and medium voltage, applicable from both ends. The twist field method, multi-core conductor, cable only, low voltage and medium voltage, applicable from both ends. In the energised cable, which is low voltage only, up to 440 volts, pulse method, single or multi-conductor cable, generator on load end of cable. The twist method, multi-conductor cable only, generator on load end of cable. This is what you would get if you buy a complete kit. There will be two generators, one for live working and one for dead working, and various attachments to receive the signal. So we look at the energised cables, the pulse method. If you look at picture number 1, the gentleman is on cable L1 and he is getting green positive lights. When he is on L2 in the middle picture, he is getting red negative lights, and in picture 3 on L3 again he is getting red negative lights. This positively shows that L1 has the generator connected to it. So what we look at is the polarity of the signal. It's either a positive or a negative signal. A positive signal will show red lights and a negative signal will show, a positive signal will show green lights and negative signal will show red lights. And then you look at the intensity of the signal. If you get an induced signal onto a cable, you can get a reduced intensity. You can trim this out by using the handset itself. The generator itself. You have a protective earth. This is nothing to do with the measurement. This protects the operator and the equipment. If there is any induced voltage that comes back into the equipment, it is put down to earth. The on button is a green button and it shows that the battery is full. Connections. Red goes to the core, which is the output, maximum of 50 volts and 100 amps. The black is a return path through earth or through another cable. The LED under the red connection, green blinking loop is less than 2 ohms. It's permanently orange, it is not connected, and permanently red, the loop is greater than 6 ohms. The Rogowski coil itself, the red coil that goes around the cable, has a direction arrow on it. The arrow must face the direction of flow from the generator. You can test the generator itself. The unit has a kettle lead which will charge rechargeable batteries. If you test the unit by putting a loop between the red and black connections, the green pulse LED must be blinking. The Rogowski coil itself has an on button. This will automatically switch off after 2 minutes if the unit is not being used. But if it is switched back on again, it will keep the gain setting that it's switched off at. The amplification should never be higher than 5, else something is not quite right in the loop. There's a leakage current, the loop is too long, or there's some sort of resistance on the circuit. A logic will check the plausibility of each pulse for pulse rate shape. It might take 1 to 3 pulses before the display will appear. So when you put the unit receiver onto the cable, you will have to wait a few seconds for the unit to actually recognize the pulse that it is what it is looking for, and then it will start showing the lights. Amplification, the gain, should never be necessary to be higher than position 5, else also distortions will be amplified as well. If you get a induced signal into a parallel cable, if you have a high amplification, you will pick that up on the induced signal. It has a 50 hertz current measurement. If you simultaneously press the plus and minus LEDs, 1 and 10 will show this mode. And what it will show is a 50 hertz supply running through the cable. It does not prove the cable is dead. It just shows there is a 50 hertz signal there, which could be an induced voltage, or it could be the cable is energized. After turning on or when adjusting the gain, the red and green LEDs will show a gain level for 3 seconds from 1 to 10. If you have a green pulse, the correct direction of flow. If you have a red light pulse, the wrong direction is a negative flow. If you have the gain set too high, the red and green LEDs 1 and 10 will show permanently on. You reduce the gain and then you will get the correct flow. Mode of operation. Connect the red lead to the core of the cable that you want to identify, the black lead to the sheath of the cable. At the far end, loop the core to the sheath, and it will then be a common earth to the other 2 phases. 100% signal will go through the core and through the coil. Separates at the end connections. 60% will go back through the coil on the cable connected to the generator. 20% each will go back through the other 2 cores. You will get a 40% difference in the 2 cores, the 3 cores, and this will show that you have a signal. So you have a positive signal on the core connected to the generator of green LEDs. The other two cores will show a red signal, which shows the negative flow. The problem, if 100% return current on its own shield or neutral will neutralize the signal itself. So where you have 100% go out and 100% come back, because there is no difference between the signal, they actually neutralize themselves and you will get no flashing LEDs at all. So it's imperative that you get the connections through the earth to separate the return signal. And there is no LED light lit at all as the signal is neutralized. If there is no connection through the earth and only to the other two cores, again, you'll get a positive flow going out. And as you have no negative flow coming back, you will just get the green LEDs. And the other two cores will show the 50% each on each core going back will show a negative flow, which will be the red LEDs. If you just show the positive going out, there will be no LEDs lit. There is no return path at all to go back to the unit. Paper insulated cables. Pulse must be able to return over the other cables or through the earth, splitting the return current. If there is no splitting the return current, then the signal will be nulled. So 100% goes out, 60% comes back, 40% comes back through the general mass of earth. %, goes out, 100% comes back through the sheathing that splits, so you get 20% at the other end as it dissipates through the core itself. This is where we would use the twisted field method, which we'll be looking at later on of the presentation. To calibrate the unit, the picture on the left shows a regulator coil at the bottom of the cable. The unit will be nulled this way. If you have it as the picture on the right, over the loop of the earth, you get a split earth return, which will give you the positive signal. Check for closed loop, adjust the gain, adjust to the max 10th position. Do not change the gain later on, because that's the way you have set the unit up, and if you change it, you may be picking up on an induced signal. Pulse must be able to return over the other cables or splitting the return current. It's for identification. So we need to make sure that the return path is split to make sure we get a positive signal on the outgoing and it is not nulled by a 100% signal coming back. Cross bonding. L1 is a return path. L2 is a positive path out. So the signal will go out on L2, returns back out and goes negative back through L1. So if you have the regulator coil on L1, it will show a red LED. When you have it on L2, it will show a positive green, which shows you that is the unit connected to the positive output of the generator. L2 now has the negative and L3 has the positive. L3 will show green LEDs, L2 will show red LEDs, showing that L3 is connected to the positive side of the generator. Identification sensor in the wrong direction. The sensor itself, if you do not have the arrow going in the same direction of the direction of flow, you will get a false reading. If you have it in the opposite direction, you will get a red LED. If you then put the opposite direction on a return cable, you will get a positive result of the green LED, but the cable will be the wrong cable because it is not connected to the positive side of the generator. It will be connected to the negative side of the generator. But as the coil is in the wrong position, it will show it is a positive signal. So it's imperative that you know the direction of flow through the cable and get the coil, the arrow on the coil going the direction of flow. Going and returning current can cancel out. As we spoke about earlier, if 100% of the signal goes out and comes back through the coil, it will null out the signal. If you get this, the best thing is the twisted field method, which we will talk about later on. So only use the unit if you can get a split return path. Energized cables, pulse method. Calibration. Set the unit up on the outgoing current towards the consumer unit from the transformer. Loop down through the earth back to the earth path back to the transformer with the returning current. This way you have the split signal and you will get a positive green identification as the arrow is going in the direction of flow. Connect the transformer to the load and the consumer unit. It will draw pulses from the cable. So it actually uses the power in the consumer unit to generate its signal. Return current must split up over the positive and neutral end of the return path, else going and return current will cancel in the clamp. In this case, again, we would go to the twisted field method. Calibration must be done on the cable connection side of the ground bar where the signal is split already. If you have it before that, you will get 100% signal on the return path and it will show no identification. Easy identify which cable feeds to a certain consumer, confirm the correct labeling. It can be applied inside a building at a fuse board. Connect the transformer to the outlet inside the kitchen and search for the pulse to the main fuse board. It can be applied in an LV street distribution box. Plug the transformer into the outlet and search each phase conductor inside the distribution box. The PASCI is another receiver which you can put over cables themselves just to purely identifies a phase of the cable. Comfortable but small pulse due to induction. You can get induction clamp. If you cannot connect directly into a consumer unit, you can use an induction clamp around the cable to induce the signal into the cable. Pulse and unstable load currents will overlay and distract the identification pulse. Again, this can lead to nulling of the signal and not recognizing the cable. Twisted field method. This would be the preferred method of any 3-core cable, as you will only put into the one cable, the return and the outgoing and the return path come back through different conductors, and through the twisted lay of the cable, you will pick up both pulses on the one cable. So identify. Red to an outgoing cable, linked over the far end to the incoming cable, and then back to the unit from the incoming cable. Going and return current are not concentric and thus will not cancel out. The two magnetic fields will appear in opposite directions, which will show you on one cable a green pulse and a red pulse. The magnetic field, 90%, no induction, thus proving that we can get signals ingoing and outgoing. As you can see, the receiver is on the high point of the cable on the green cable, the green-yellow cable. You will get a positive green pulse. As you move along and the cable starts going down through, you start losing the green pulse. When you get the receiver on the return cable, you will get a negative red pulse. And when the receiver is on the lower part of the two cables, you again get no pulse. You could also do the twist method, where you can actually get the receiver and roll it slowly around the cable to pick up on the high points of the positive and negative cable. So as you go around the cable, you hit the positive outgoing cable, green pulse. Away from both cables, no pulse. Around to the negative cable, red pulse. Back to no cable, no pulse. So you can test the cable either moving the receiver longitude across the cable or around, transversal around the cable itself. So if you have a very long twisted lay of the cable, you may not need to open a huge pit up. You can have a smaller pit and go around the cable. If you have multi-core cable, always try and use the outer cores of the cable as the pulse is higher and close to the receiver. Important also here, keep the amplification low. Confirm by using longitudinal and transversal twist. Longitudinal twist might also be seen at a small distance of the target cable. This can be dangerous wrong identification, as you can potentially get an induced signal into a parallel cable. Some power cables have a very long twist. Confirm this by using longitudinal and transversal twist or the pulse method. If you do get an induced signal onto cables, if you reduce your gain slightly, the induced signal will die away and just the main cable with the generator on will show a positive signal. Connections from the transformer. You have the red goes to one core, the black goes to another core. The far end, you loop the two cores together. This will give you your positive and negative flow. Going and return current can cancel out. Again, if you get the 100% going either way from the pulse method, use a twisted field method. If you do not pick a pulse up, then try the different receiver. Twisted field method. As you can see, the unit is set up, linked over at the far end, and then you can look at your high points and your low points. As the yellow core is connected to the positive side and the blue core connected to the negative side, when the receiver is on the high point of the yellow core, you will see a positive green display. When the receiver is on the high point of the red core, the blue core, you will get a red negative pulse. Connection to the live cable. Connect the earth, protection earth to the earth system. The red and the black cores to cores. The direction of flow must be towards the transformer as it goes through transformer and the star point completes the loop and you get the positive and negative signals. Reminder again from the pulse method, if you cannot get the signal on the pulse method, use the twisted field method. This is the preferred method for multi-core cables. Identification is only possible in the direction path of the current from the customer connection towards a transformer or the distribution box. Identification not possible in closed ring systems, as there is no loop point to complete the circuit. It must be an open ring with a connection at one end. Photovoltaic systems are also a feed-in source. This must be disconnected. Compensation systems can temporarily feed power due to phase shift. Again, these should be disconnected. Parallel cables must be disconnected where possible. Current must not be split between the two parallel lines. If calibration is not possible at the customer's load side, direction can be checked at the transformer feed-in side. 50 Hertz load current on the cable should not be higher than 150 amps. If it's higher than 150 amps, it will mask the pulse signal from the generator. And don't use a higher gain setting than 5. Identifying with audio frequencies. You can use an audio frequency unit to look at the twisted fields of coils. Safe identification is only possible with a defined return path. It is not recommended, but it can be used. When you get to the two high points, you will see a raise in the signal itself. Phase identification. We're looking at phase identification with an instrument called the P8 and with a cable identification unit. Should the earthing and short circuit of medium voltage cables have to be removed during tests and measurements, then suitable alternative safety precaution must be taken to ensure safe working environment for the technicians. Always make sure you have a earth, even if you have to put a temporary earth in position. The P8, a phase identification on de-energized grounded cables, a single person operation. You have a generator and receivers. You will set the generator up onto a cable, and the cable that is connected, the far end will have a coil which has its own unique signal. L1A, L2A, L3A, L1B, L2B, L3B. The unit itself will recognize the signal from the coil of the receiver and tell you on the screen what cable the clamp is connected to positively identify that phase for marking up purposes. As you can see in the picture, how the units are just clamps. Clamp on, each clamp has its own individual signal, and it will tell you what clamp the cable is connected to. With the CI cable identifier, cable is grounded in station A and B. 2 workers with remote communication are required for this measurement. Set the unit up to a midpoint with crossover connections. Either side, at each substation, it should prove what core is connected on the positive side. This will show green positive lights. Any questions, please type in now. If not, my email address is tony.walker@megger.com.
right, great. Thank you, Tony. Thank you very much. Very well presented. Now we are at this Q&A session. I don't see much question coming in. Feel free to ask question here. Our expert Tony Walker could be of assistance to you.
Yeah, I will always be available. People have my email address, or they can go through Patrick or one of the Megger representatives in Asia.
Yep, definitely. I think your presentation is quite detailed enough. We sell a lot of CI in this region to identify the cable before they cut and repair the cable. I think in principle it's quite easy to handle, but yes. I'm not sure any engineers or operator here who experience our CI. If they have any question, they can raise out their questions.
Yes, we do have some training videos as well with the CI, which will always be available if you would like them.
Okay, great. I think maybe the CI is too easy to handle, so there's no much question.
We try hard. It's easy.
Yeah. But I believe this is very important. You know, they need to understand the system. You need to de-energize or using the CI set, or the energize using the LCI set. You know, not
yes,
to mix up.
Yeah, the LCI set is for it uses the voltage on the cable. So this is only for LV cables up to 440 volts. The dead unit can be used on any dead cable. You just have to make sure there's a loop at the other end. So if you wanted to identify a cable that's been in the ground for a long time and you wanted to prove that it is the cable you're looking for, you can go to one end, link over the other end where the pit is. You can say, yes, that's a decommissioned cable. So it has various uses, so you can use it to identify when you've cut a cable and you've jointed it to make sure you joint the right sections up. You can use it on new installations where you're jointing in a remote area to make sure that the phases are connected up correctly. You could use it for looking at decommissioned or unused cables, or just looking at cable runs to identify cables possibly above ground in industrial situations where you have many cables that need labeling up. So there has quite a lot of applications, the CI.
Correct. Tony, I think there are some questions coming in. The one from Nito, he's asking, what is the maximum distance between generator and receiver?
It's difficult to say because it all depends on the resistance of the cable and the attenuation in the cable where the signal can be lost. But you can quite easily do 3, 4, 5, 6 kilometers I've seen on cables. Again, you would just have to have the gain quite high at the very far ends of the cable. But I've had it 3 to 5 kilometers.
What is your experience using this CI on the longest cable?
I've had no problems, issues with it at all. If you're in a pit and you've got half a dozen cables in there, you will sometimes pick up an induced signal. But if you use the gain, you may have to reduce it slightly. The induced signal will die away and you'll just pick up on the positive side. There's not many scenarios where I haven't been able to identify a cable pretty quickly. A few times you have to alter a few things, and what we have had in the past is we had no signal on the cables in the pit, and when we used a line locator, we found that there was more cables and the pit had to be widened up, and then we found the cable we were looking for, just the drawings were incorrect at the time.
I think the most challenging part is not the length of the cable, right? What you're telling is more to the access to the cable and the network of the cable. That is the more challenging part. Yeah,
you have to make sure if your drawings are incorrect, don't immediately assume that when you dig a hole up and you can't get an identification on the cable, that the cable you've lost the signal is not getting there. There's a very strong possibility that the pit may not be deep enough or wide enough, and the cable could not be exposed at the time.
Correct. Yep. Agree with you. There's one more question from Ahmad here. So,
yes,
as mentioned in your presentation, 50 hertz can be identified by all cable identifier also. I don't understand.
The CI itself, if you quickly press the positive and negative, the gain up and down buttons on it, it changes the receiver to pick up on a 50 hertz signal. So you could put it onto a 50 hertz signal and say, yeah, there's 50 hertz there. It doesn't prove the cable is energized or de-energized. All it proves is there's 50 hertz there. It could be an energized cable, or it could be an induced signal that it's picking the 50 hertz up from. But yes, it can be used to identify if there's 50 hertz into a cable.
Oh, they can identify 50 hertz into the cable.
Yes, it will tell you if there is 50 hertz in that cable.
All right. Okay, interesting. Can you show me which page of the presentation for this one? Is something interesting for me?
Just a quick look.
You mean the CI can identify the cable is live or not live? Is it?
It doesn't prove it's live or not live. What it proves is there's 50 hertz there. Don't take it as a proving dead unit.
All right. Okay.
There we go. If I share,
probably share back to the.
Okay, can you see that?
Yes.
A 50 hertz current measurement by simultaneously pressing the plus or minus LEDs 1 and 10 will show in this mode. Measurement shows only current flow. It does not show that the cable is de-energized. All it will show is there's 50 hertz in there and a current.
Okay. All right.
So you put it onto a cable, and if 3 cables had 50 hertz on it and 1 cable didn't, then you could see that that hasn't got a current flow or a frequency through that cable.
Okay.
I wouldn't use it for proving dead, but as a quick check where you've got the receiver with you, you can say yes, 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 no.
All right.
But you still need to prove dead, that the unit is dead and earth down.
Yes, of course. Good. Thank you so much.
Okay.
Hi, Tony. The last question for me. Yeah?
Yes.
Yeah. Is there any limitation in which situation can be tested and cannot be tested?
The limitations of the cable, if you're using the twisted field method, it needs to be a minimum of 2 cores. It needs to be a multi-core cable. The limitations with the pulse method, with the Rogowski coil, is you need to separate the return signal. If you don't have a separation on the return signal, if you just had 1 core going out and it wasn't connected to anything else, it wasn't on a common earth, then you don't get a split signal. What you'd need to do is separate the earth somehow. So whether you linked over to another cable's earth, so the signal splits. Because if the signal doesn't split, as 100% go out and 100% come back, now the 200% null each other to 0, and you will not get any signal, so you cannot prove the cable. So you would have to somehow split the return, either to another cable or possibly down to an earth point somewhere. That's the sort of limitations on both the methods.
Okay, good enough. Okay, I think that's all.
Yep. I think any more? Should we wait 1 more minute? Let's see if any more questions coming up. And we will have another session for from you, right, Tony, next Friday, the Digiphone Plus 2. Yeah.
Yes.
That is the excellent product. Yeah.
Yeah, it's a brand new product out. It was only released probably 3 weeks ago.
Exactly.
So
correct.
Very new system. I've used the unit a few times, and it's just got a lot of improvements from the Digiphone Plus. There's some nice little bits to it. It also which we'll go through next week. It's a complete unit now with the line locator. We can actually build in the Ferrolux with the system as well. So I'll do like a joint presentation between the Digiphone Plus 2
Okay. All right.
and with Ferrolux as well.
Will you do only Digiphone Plus 2 next Friday, right? Not to combine with the Ferrolux, am I right?
I can do both if you'd like it combined with the Ferrolux. It will tell you in the presentation. It's quite a short presentation because the unit's so new. It will show you the head unit is a multi-head unit, but it won't go through the Ferrolux. I do have some videos on the Ferrolux that we can always play afterwards if people would like that.
Okay, the topic plans next Friday is only Digiphone.
Okay.
If you think that you want to do a tracer, we can plan in October. We have another session for October for you. That would be great. We can do the what they call the tracer, the new Ferrolux, yeah. And then probably at the end of the presentation, you can combine a little bit the option to add Digiphone Plus 2. That we can already this month, something like that.
If we do a cable tracing one in October, then we'll combine it with the new Pro Trace, which is just about to be released as well.
That's much better. That's much better idea. Then we can do Pro Trace and our products together next October. All right.
Yes. Then we'll do that.
That will be good. Good. All right. Good.
Okay, guys.
At least we hear from you every month.
Yeah. Until I can come back over.
Great. I hope so, because now the regional is still locked down. Anyway, no much question from all of you, so I think we close this webinar, and we look forward to see all of you again next Friday. And thank you very much for joining. I pass this over to Chris. And thank you very much, Tony.
Thank you, Patrick. Thank you, guys. Have a good day. Stay safe.
Thank you. Thank you, everyone. Thank you, Tony.
Thank you everyone. Thank you, Tony. Thank you, Patrick and Nino and Ahmed. So before you leave, please fill in the survey form for our improvements. Thank you.
Thank you very much. Cheers. Bye-bye.